Well, we have quite a show tonight for people that like flowers and hard plants that you can grow outside here. We have tonight the rep from Pueblo, Colorado. A longtime friend of several of us, Jeff Thompson. Jeff has been messing with cactus for about 50 years. And in the last couple of decades, he's gotten really interested in making hybrids in Echinocereus. And he's crossing some stuff. Now I've heard that Jeff, he works up at the lab in Pueblo. It's already bizarre trends now. So you're going to have a real treat, a piece of beautiful flowers. And the good thing is that most of these you can grow outside here. So thanks very much, Jeff, for coming.
Very welcome.
Go, Jeff, go.
All right. Yes, I will say that hybrids are probably part of the future. It's the same thing in other flowers and flower beds and stuff we've been working on for years on cultivars and different things like that. But we're just getting started with cactus. They have been working with Echinopsis for quite a few years, but not much in any of the hardy type cactus. And one thing I wanted to stress to everybody, the importance of pure stock still, you know, we need to preserve our species too. And we need to do everything we can to keep them pure. But there is definitely going to be room for hardy hybrids, because what I've found out up there in Colorado, that crossing some of these different species, I'm actually in most cases turning out with stock that is hardier than the original species, which is unbelievable. But I'll start into some of this. I'm going to tell you a little bit about ploidy. And that's dealing with chromosome counts in cactus. We did, thanks to the Germans in some respects, they did a lot of work on Echinocereus. And of course, Opuntia and Cylindropuntia, they did a lot of work too. But some of the other species, you can't find much material on chromosome counts and different things like that yet. But I know eventually it's going to come, you know, in the future we'll have ploidy of just about all the species. But thank goodness I work with Echinocereus, so it's really helped me learning ploidy and what you can cross and what you can't.
Gary, the light, is that possible? Over the screen? Of course.
I was just going to comment, the reason you're interested in ploidy is to make seeds that are
fertile.
fertile,
Yeah.
and maybe those plants you want to be fertile too.
Yeah.
Compared to mules.
Yeah, there you go. That's what I'm going to show you a little bit. You know, if you keep your ploidy right with your breeding program, you can continue on your lines for years and years. You make the wrong cross, then you get an odd number, and a lot of times the new plants come out sterile, and then you're dead. You can't do anything further with them. So let me see if this is gonna. It's not clicking.
We need a better audio visual department.
I think we're paying too much for it.
Well, are you going to be a regular member? Yeah. Man, we got to sign you up. You know what you're doing. I'm stumbling around.
Just hit the space bar.
Yeah, well,
We might have to get back into that.
I'm about as computer savvy as the earth. So,
Okay, let's see.
just try the cursor too.
Well, I want to know what happened. We had it working at your house.
Now, there you go.
There we go. Now, let me see if it works. Yep, now we got it. All right, here we go. Ploidy. What means the number of complete sets in a chromosome in a cell. And we're showing here the different types. Diploid, 2X, 2 sets of chromosomes. Triploid is 3, which is, you see at the end, I show sterile. You need to keep your ploidy as even numbers. When you go odd numbers, it becomes sterile. Now, in Echinocereus, we go clear up to a hexaploid. Your Cylindropuntia, I think they go clear up to hexaploid also. But in Apuntia, they've even found some octaploid so far. But I wanted to show you all the different types. Yes.
2 sets, you see that, the textbook images of the DNA unzipping when it's just 2. How do you deal geometrically with 4 sets of chromosomes?
Well, I'll show you a little bit further here.
Okay.
All right. Everybody is, oh, well, I went the wrong way. All right. Okay. Now, in every species, the pollen and the ovules carry half of what the species has. And when you cross it with something, you get another half. So it's real simple. As usual in the wild, if you got 2 different diploids in a species, you're going to come up with diploid because you're carrying 1 from each. So it's real simple, once you get to knowing this, it's real simple to figure out. All right, now if you take a tetraploid, which is 4X, it transfers 2X. And if you take a triploid, if you take a diploid and a tetraploid, they transfer 1 and 2. So automatically you're going to get a triploid, which is 3, which would be sterile. So this is 1 cross you don't want to make. Below that, you've got another one, tetraploid with a hexaploid. You're getting a 2 and a 3. So you're getting a pinaploid, which is 5. So what you can do is now here down at the bottom, you got a diploid, which is transferring 1, the hexaploid that transfers 3. So now you can actually produce a tetraploid, which is going to be fertile for you. Does everybody understand that now? It's, once you have it laid out, it's pretty simple to learn. All right, now I went ahead and showed some of the ploidy of some of the different common Echinocereus that we have around. And you can see Coccineus, Daisyacanthus, Egomanii, and Fasciocollatus, which is a form of Egomanii, are all tetraploid. You get back over to Arizonicus, you get Mojaviensis, Triggs, Viridiflorus. Now, I will say in most of the Echinocereus, there's a heck of a lot more diploids than there are tetraploids. Now, we have Baker defined the new Yavapai-ensis, which is out near Prescott in Yavapai County, and it's actually a hexaploid. It's the first hexaploid we found in Echinocereus. Most of the plants in the Echinocereus have been identified. There's a few in Mexico that we haven't had showed ploidy on, and then there's a few in Baja still yet that there's nothing shown on them yet. But anyway, now here's one of your natural hybrids from the Arias. Well, I've been working on them things about as long as I have been anything. And just crossing them back and forth, different hybrids, I've come up with some of the most unbelievable colors on them. You could imagine too, some of these pastels and greens, and there's a little bit of everything.
You can see the show in nature too.
Yeah.
It's just like this in nature too.
Yeah. And this is the one from the Harias here in New Mexico. Now, the cross of that one is a cross between, originally, it was a cross between Daisyacanthus and the Coccineus subspecies rosei. And what produced these hybrids. Now we go down to Texas. And, you know, I see this a lot on Facebook and all over the place. They say, well, they're the same. Lodi and Roteri are the same. They're not the same. The Lodi from down in Texas are crossed with another subspecies of Coccineus called Pachyspinus. Now, one thing that's different between the Lodi and the Roteri is the Lodi see a lot more Arctic cold. Even though they're further south on the front range, we get them storms that come down through Colorado and they go clear down to Big Bend. But a lot of times you guys don't ever see them over here. They don't get over the mountain. So this one, the Lodi that I've had out in my yard for, good God, 30 years, I've never lost a Lodi to cold. They are hardy, really hardy. Whereas about 50% of Roteri up there are hardy. Now, Roteri should do fine down here, just about every one of them. I don't think you guys would have any trouble at all with it. Here's a special Lodi that I came up with. It even had almost a black center to it. You can see the spines on that plant too. And I'm in the process. I took these when they were young and I threw them out in the garden. And I thought, you know, I wonder if they accidentally got crossed with something else. And I'll be darned, every one of them out there in the garden produced seed. So I said, well, they ain't gonna be in the garden, they're going back in the greenhouse because we got to get this cultivar out. It's just crazy how beautiful that Lodi is. And here's another one, another mutation. It's actually a multi-petaled Lodi. And this is in the progress of what all your other cultivars and flower beds have ever did. You know, like your carnations, your dahlias, everything is multi-petaled. This is going to be our goal too in the future, is multi-petaled cactus.
You have another one?
I've only got one that came out like that so far. So I'm crossing it back and then I'm going to try to use genetics to get it to come back out again. This is the sterile hybrid. And it's a cross between a Lodi and a probellus. But my gosh, you can see the flowers on them things. So some of this sterile stock that we do produce sometimes with the advent of cloning now, we might be able to clone some of these varieties out too in mass for the gardens also. And you can see where there might be a need for that later on too. There's lots of tissue culture places in the United States, but a lot of times you have to give up the plant too. So,
But have you ever looked into it yourself?
I haven't. I think what needs to happen is some of you young guys need to learn that technology. I'm getting the age, you know, I'd love to learn it, but I don't know if I got that much time. So, yeah, some young people need to start working on that.
But by the way, it's not that hard to tissue culture. Where I live in Centralia, Washington, there's a warehouse research laboratory. And we were trying to clone our Douglas fir trees for a bunch of reasons that complete stupidity as far as I can tell. But actually, they could never match what a housewife in town was doing, cloning strawberries in her kitchen, with just an oven and a pressure cooker and stuff. She was legendary around that.
No, some people have the art. I know that. Yeah.
She wrote a book on it.
But anyway, it's something to, to think about for the future. Some of these sterile hybrids. And, there's.
As long as the parents are alive, you can keep on making.
Oh, yeah.
Yeah, well, quick question. If you take either one of those in the previous slide, and you go ahead and put the fertilizer to them and push them hard, they should offset like a fan.
Yeah, either that or even grafting.
Yeah.
You could do grafting and really increase your numbers.
Yeah. Or
So if I would think about cloning something, I would probably do one of them, things to make sure that I'd get more pups and different things. You could always, graft it, cut the main plant off of it, and then it's gonna offset a lot of young pups. So this is a few more pictures showing the plan of that Lodi, and you can see some of the dark in the spines there that almost reminiscent of Probellus. But they're definitely hybrids, sterile hybrids. All right, this is where I started out. Years ago, miles ago, a lot of you probably know that nursery down in Tucson. I was talking to him. He said, Jeff, I crossed a bunch of Fasciocaulatus with Deladii from Mexico. And he said, I got these hybrids. I said, well, send me up 8 of them. Well, I had 8 of them. I threw 3 of them out in the garden. Well, 12 years later, they'd taken 20 below like it was nothing. And this is where I got some of the ideas for this hardiness with hybrids. I mean, you got 2 different southern plants there that shouldn't be hardy in Colorado for sure. And them things never got damaged whatsoever, and they bloomed every year. And here's what the progeny looks like. They almost look like a Apacheensis, but they have a lot lighter colored flower, more like Fasciocaulatus. I did try a cross with them with the F1 hybrids. It went all over the place. I got a lot of weird stuff. So I did make the cross again myself, and the plants come out identical to this again. Now that's not guaranteed. I've taken different other species and crossed, made the same crosses sometimes, and I don't get the same results. So different plants of the same species a lot of times will not throw the same as what you got before, unless you use them same plants, and that's still not 100% guaranteed that you'll get the same results. Like I said, there's a lot of this that's not, it's not science. I mean, it's not, you can't put a point on it. Now here's a beautiful Trig Probellus hybrid. We call this one Red Beauty. But it's really red, and it's got, as it ages, it gets a little pink in it, and it's fertile. You're talking 2 different diploids for the cross, and it's completely fertile, and you can continue on breeding with it. Here's some of the other flowers that I've got out of them crosses. Now here's a cross of a Trig and a Bailey. And you can see how intense red that flower is.
They're indestructible here. Wow.
Yeah, and them things out in the garden up there are indestructible too. Yeah, Bailey are, they're pretty dang hardy anyway. And of course, you get a Trig, a northern Trig, Colorado one, and you cross the 2 together. I don't even know how low these could go. They might go down to at least a zone 4. Yeah, probably. Okay, this is another, I got into the Rhizanthus canis type, cross these out. All right, Canis up in Colorado goes down to about 10 below. So does the Rhizanthus. It's about 10 below, both of them. They're both from down in, one's from Presidio and the other one's from Brewster County. But I crossed these 2. And I got these. And that one takes 20 below like it's nothing.
It looks like the population is down.
Yeah. I wonder if they had a natural hybrid cross down there somewhere. They might have. But they almost have them chocolate colored flowers, which is really unique. Now I took the F1s and crossed them, and look what my results were. I got a lot of different directions there, but A lot of them were really nice. I mean, look at the green on that olive green on the center. You got the chocolate with the red. And then we even got that caramel colored one on the side.
So to get 2 generations of seed, you're talking basically a 5-year project?
Well, you got to raise them up.
Yeah, that's what I mean.
Yeah, so it's 5-6 years.
Yeah.
From the time you make the first generation of seed.
Yeah, that's it. But, you know, surprising, most of your plants in the Viridiflorus complex, they bloom early,
Yeah.
quick. A lot of times I'll have them bloom at 2 years old.
1 year.
Yeah, I haven't been that good yet. Now here's another cross I made. This is Apachiensis with Bailey. And this was actually an accidental crossing. But what the heck? I raised the dang Apachiensis up, and here's what I got. And they're gorgeous. I haven't tried these out to see how cold hardy they are, but I'll bet you anything with Bailey involved, they're going to be cold hardy. But look at the size of the flower and the color.
Where's the patchen?
It's from Maricopa County, Arizona, right up above Phoenix there to the east.
From the mountain.
Yeah, up in the mountains there. There is Apachiensis around there, other areas, but the best population that I've ever seen is up there in Maricopa. It's up there in that, I can't remember the name of that area there. No, it's, no, it's not the Barnhart. That's too far up high.
I've seen them.
It's called Fish something, but I can't remember the name of it. All right, you're talking about a beautiful hybrid. And look what it says up there, it's sterile. And this was another crossing by accident, and I produced these twice. So regardless of whether it's sterile or not, plus they're hardy. Anybody, you know, give a lot to have a flower like that in their garden.
If it's by accident, how do you know exactly what the cross is?
Well, you can look at the spines and in the relationship where it was in the greenhouse and this and that. You know,
Okay, so it's reverse engineering.
yes, plus I did the breeding myself after that. I raised a batch of them. They instantly sold. They were gone like candy. And then I raised another batch that I had made the cross, and I got the same results. So,
That's okay.
but anyway, that's, yeah, Daisy Acanthus, which is a tetraploid, back to a Finleri, which is diploid. And you got
Really interesting how the flower colors merge, just like you would paint.
yeah,
It's amazing that the chemistry that creates the pigmentation mixing, just like you were
mixing paint, yeah,
yellow and purple paint.
yeah.
From the beginning of that flower to the end of that stage, the even coloration from the time.
Yeah, all flowers will change their color a little bit, some more than others. That one turn a little bit more different colors as it ages too. Now these, some people would think that them are Mojavensis inermis, but them are actually hybrids. And them are crossed with white sand back to Mojavensis. And I've got one up there, I didn't have a picture of it in bloom, but one of these, this is the same plant. That's winter and summer. And that's how that thing turns in the winter up there. Yeah, ain't that gorgeous? Every year it turns that color. But you can see it blooming over here. That's actually two plants there together. Now I finally broke down this year, and this last fall I started a big flat of those. So I'll have these coming up too. But I've got one that's known all over the world now. It's called cucumber. And it really came out. It's over, oh my gosh, they lay out on the ground almost 14 inches. It's that big, but it's white sands and enormous crossed.
And it's spineless, more or less.
What's that?
And it is spineless?
Yeah, most of them are pretty well spineless. This one here, both them plants, that's why I put them out in the garden, they're completely spineless. So I'm anxious to see how their progeny comes out too. It's in Colorado, Pueblo. Yeah,
Do you have a lot of rabbits in your yard?
I have a few. I got one that lives out there year round. And sometimes I have to watch spineless plants with him too. Yeah. That's why, you know, on some of them enormous hybrids I brought you a bunch of spine ones too. Because a lot of people, if they have rabbits, they might want to have the spiny one. Because the spineless ones will get ate a lot of times. All right, this is the Coccineus probellus. Coccineus being tetraploid 4X with probellus 2X. We got another sterile hybrid. But ain't that a beautiful damn hybrid? But there again, we talk about cloning. Some of them come out yellow with that pink and some of them come out orange with that pink. Yeah, I couldn't tell you, Steve. Yeah, I know. Well, sometimes it just blows you away. You wonder how you get some of these colors.
But the thing is, the colors are probably number 15.
You know, it could be the amount of color and what it reflects. If it's not as thick, the color, maybe it'll reflect more yellow than orange. That's the only thing I could tell you it might be. All right, here's another. This was a volunteer out in the garden, and I took it in, and it turned out to be a chloranthus crossed with an albuspinus. And you can see over there on the side, that's a young albuspinus that I was crossing back into it again. You can see the color of the flower. Well, you can see the color of this adult here, which is really different. But look at the hybrids I got out of this. Now I had two of these come up out there and I crossed them together and I lost the other one of the parent. They were real similar, but I got seed out of them for the first generation. But look at some of these flowers I got out of that first cross. Yeah, look at there. And then the last one will really blow you away. Look at that thing. Yeah. So there's a lot of beauty you can get out of this breeding, you know. I find out one of the right that's the same plant right there. That's a younger version of it, and this is an older. I wanted to show you. Okay, now if some of you know chloranthus, they change color as they age drastically. So a lot of times they'll start out green and then they turn brown. Well, there's your chloranthus ancestry right there. And it's really bringing it out vivid. So, oh, here's another cross I made. It's a gentrii from Mexico. I crossed with the enormous, and there again, gentrii is diploid. So you got a fertile cross here too. Now these things, when we talked about the rabbits, I put some of these out. Leo, I gave some to Leo up in Springs, and he put them out. Well, his were doing good. Well, all of mine got 8. So I couldn't test them. But he said his did great in spring. So that's another Mexican species crossed with an enormous, and it made it hardy. Or just as hardy as an enormous. But you can see one thing I was trying to accomplish with this end of it is trying to start putting some of these primitive flower tubes into some of our hardy garden plants. That long tube doesn't exist much in the States. It's all from Mexico. So maybe eventually I'll work a little bit more on that one, and I might have to give it spine.
You get a lot of, birds and everything.
Oh, yeah, we get a lot of hummingbirds in the garden. Lot of bees, a lot of everything when this stuff is blooming, so. Here's a F2 of the hybrid cross. They come out almost miniature, but look at how they're multi-clumping. But a lot of them come out with that purple winter color too. But they're only a third of the size of the original plant. So the weird genetics in play here. Sometimes with them F2s, you don't know what you're gonna get. All right, there's the famous copper. That was a volunteer out of my garden. And I brought that thing in. And I've crossed it with a gentry that gentry hybrid you seen the last slide. And I got these. That you can see there, they're, a lot longer tubes, stems, and then they had some weird different flowers to them. The next thing I took copper. That was that cross produced quite a few variegated. Now they have proved that variegation is from virus. And what I do believe it is genetic weakness, which causes variegated plants. All right, this was the most phenomenal cross that I've made so far, except, well, I got one more besides that, but this one here, I took copper and I crossed it with a Corellia. And oh my gosh, I could never dream what I got. That's all F1 progeny.
I'm curious to see what you have to do next year.
Well, I'm raising more batches, but I'm being careful. The last cross I made was all of these F1s. I'm crossing back to copper. So instead of going between themselves, because of all the variants I've got on the other stuff before.
And are you looking for different flowers or are you also?
I'm looking for the plant, stem. I'm looking at all kinds of things. And the other thing that I'm looking for is completely spinal. Because I want to produce good enormous with these beautiful flowers. Yeah, well, I might have to put some fences up or something.
I have a question.
Here's more of them.
So is that the variability just between crossing two plants or?
Them two, that's just them two crossed together, and I took copper seed and planted it. And I got all of this. Yeah. And we even got green.
Yeah. Good question. So copper produced seed, but the other plant also produced.
Oh, yeah.
Is there a difference in the?
I haven't tried the Corellia seed. I've got it, but I went ahead and stayed with copper. And it might be fantastic too. I don't know.
When I've done crosses between Humans and Sclerocactus, which one is the mother, so to speak?
Yeah.
Seems to affect the stem, the size of the plant, the bigger.
Yeah, I thought that too until I did some crosses. Then there again, it's not completely science. I can't put a finger on it completely. But yes, I do agree with you. Most of the time, what I've had happen when I've used the seed from both parents and started to flat, a lot of times they're completely different.
The stems.
That's it. They look completely different. Yes.
That bottom center one, got two different colors on it.
Yeah, that's a pink that come out. Good sized flower.
Does it age?
And you can see the new flower opening up the color. It's that real, I don't even know what color of an orange you'd call that, but then it turns that pink as it ages. So, but I tell you what, look at that brown up there. I mean, you're talking about something unusual.
How old are those plants?
These are going on, they're starting to get some size on them now. They're about what is it? They're probably 6 years old now. And they just keep getting more and more floor abundant as they get older too. I mean, you know, they're young here. And look at the flowers they're producing already. So here's another batch of them.
From the same crop.
Same cross. Yeah, you notice the spine ones down here that came out too, but look at the yellow and the brown on them ones that look a little bit Corellia. And then here, where did that one come from? That pink. Look at the spines. Look at the stem and the spines on that. Really strange, but they're all fertile. They're all diploid. You could, you know, you can't hardly believe they're all from the same seed. But
Means we don't understand the science.
there you go, completely. You don't understand the sign.
We don't understand.
Yeah. But it's, you know, it's what I even said on Facebook a couple times to different people. I said, you know what? I could work on just Copper's babies from Corellia the rest of my life. There is so much variance there. I don't think I'd ever conquer it all. I mean, my gosh, just crazy.
Or stabilize it so that you.
That's it.
Yeah.
That would give you a certain plant, a certain color.
All right, here's my last cross. That's another volunteer from my garden, that big pink. And of all things, where it came from, but it's got a medium long tube on it too. And where it got a primitive part of a primitive tube from, I have no idea. I don't have no primitive tubes in my garden. Is it a genetic throwback from way back or something or what? But anyway, it conveyed into the babies too, as you'll see. Now look at that. Yeah. All right. The plants I had over there for sale, this is the few that bloomed last year. So these are them. Now there's your orange with the violet outer edge. Just unbelievable. Look at the spider bloom on this one.
Well, even the petal structure is different.
It's completely different. Well, now look at that one. That's out of the same batch, that red one. Look at its petal. And look at how dark a red that is.
Jeff's been getting the sauce.
Yeah. Now, the exciting thing about the one over here that has the fuchsia pink, look at this. Now, look at the primitive tube. But look what, did everybody notice what's crazy about them two flower buds? Steve, could you notice? You got it. Two buds from one area. Now, in all my life, I've never seen that.
Wow.
You have seen it in phylum though? All the time.
Volunteer on that one.
Yeah, I might have had one a little one that was a seedling when I transplanted it into this. These are real young. They're only like, they're going on 4 years old is all. Them plants over there are the same age. Yeah. All right, primitive tube has long tubes compared to most of your modern tubes are really short. And most of our United States Echinocereus have modern tubes. But down in Mexico, you'll find a lot of them, like Gentry Eye is one of them. That'll have a really, really long tube to it.
Have you looked at the plants that are, I'll call them boavensis, that are, say, west of Flagstaff, maybe down where the turnoff is to the Supai Indian
No,
village? They have long tubes.
they're the what now?
They have long tubes.
I mean, what species?
I'll call them boavensis. I would call them tree until.
There's Malvensis down there.
Yes.
and they have long tubes.
Along the interstate.
I'll be danged. Well,
I think it's either the interstate or there's a little bit of a loop.
I think we need to take a look at them. It's got primitive tubes on some of them.
I may have some in my car.
Yeah. Take a picture, Ralph.
I will.
But, hey, you know, that blows you away. You got a primitive tube on here and then now you got a double blood on one area. So. All right, here's a picture of quite a few of the ones that bloomed last year. And I think that's it.
So what's the consistently said primitive tube versus short or modern? Is the real historical evidence?
Well, we
What is
think,
that terminology?
all right, we think that most of the primitive tube was original. It's the ancient. And, you know, we think Echinocereus, they probably evolved from different ceres years ago. And most all your ceres were primitive tube night blooming. Now, gentrii is night blooming. Some of your primitive tubes, your long tubes like that are night blooming. And most of our United States modern are day blooming. So that's another aspect of primitive tube. Now, these are blooming during the day. They've got somewhat primitive tube, but they're blooming during the day.
So our Echinocereus, the Libyans that have the rockets.
Almost all your lobibias, all that stuff in South America have primitive tubes. Yes,
So that's considered over development.
yeah. Well, how you can really compare it, your modern stuff is new age. I guess that's the best way to explain it. Yeah, your shorter tubes are new age.
These guys keep the flowers open at night. Or-
No, a lot of them close at night. So, but some of them stay open. Like, oh yeah, they'll reopen if they do close. But a lot of them stay open too.
Couple of days, depending on the weather.
Yeah,
Per flower.
yeah, they'll stay open for a while. It all depends on how fast, a lot of times how fast I fertilize too, or pollinate.
Oh, yeah.
So if I don't pollinate them for a while, they'll last a lot longer.
You get frustrated.
Well, that's it, people. Any other questions?
Third or fourth slide in, you had a beautiful red.
Yeah. Well, you know, I've never got into it, really looked at it real close, but it probably is like a deep red or something. In most cases, that's what it usually is. It'll look almost black, but it's actually a real deep color. So.
Everything I've seen before.
Yeah. Yeah. Anything else?
So what do you think the hardiness is on this hybrid here?
Well, you know, I know that, you know, copper and the big king come out of the garden and they've taken 20 below. So I know that I'm sure that they'll take 20 below. Yes.
I was gonna ask, do you think, what do you think the evolutionary advantage is of having a surface versus the line?
Well, I think it's the advent of different bees and different things that came along. And they just changed pollinators. You know, a lot of your primitive was night, so it's moths, bats, different things like that. It was just, they adapted to the pollinators. And the best we can explain.
As they move north, maybe?
Yep, possibility. Less of the moths, less of the bats, maybe too.
Kind of hard to find.
Well, I'd give them a little bit of shade if possible, because you get pretty hot here.
Yeah.
So, you know, their original inermis are from, you know, Grand Junction down through that area. So they get, you know, they get quite a bit of cold and then they won't get quite as hot as you do.
So they probably want some early season moisture.
You know, if you got an east exposure, that's even better. Yeah. You know, I don't know if all of you know that morning sun, eastern sun is a lot better than western sun. Western sun will burn. So if you got an eastern exposure or something like that, that's a lot better.
Are these
Okay.
hybrids sterile or?
They're fertile. They're pure diploid. Yeah, they're fertile. You can continue to work.
When you got them out in your yard, there's no telling who's gonna.
Well, yeah, it's hard telling what you get out there.
Right.
Self-pollinate out there. So what the people do there.
Right.
That's it. Yes, I do all my greenhouses right now. I went to the extent with my greenhouses, I have roll up, 6-foot roll up sidewalls on the commercial greenhouse. I went in there with shade, window screen, and covered all the same things up. Then I put chicken wire over that for the coons and everything else they couldn't get in. Squirrels. So I protected them from even over the fence, I put the screen.
Right.
So I tried doing everything in my power, and I also did that for our species too, because I want to keep that seed that we're culturing pure of our species also. So,
I got one.
yeah. Yeah, that's looks like a pink rhodorite from the Harias.
For the higher ploidy plants considered to be more evolved or?
Yes, yes. Yes, you know, when we talk about diploids compared to, let's say hexaploid, six sets. What we believe that your diploid was the original. And as they graduated with more ploidy, we don't know how they did it, but we know that they have. As they got more ploidy, they've evolved more and more and more. I mean, my gosh, in Aputia, we have an octoploid, 8 sets. So it showed you how prickly pears have evolved. We know how adaptable they are. So, yeah.
Are they very simple?
Yeah. Anything else?
Steve, I think you got a question from Chad.
Oh. Where's our? EV guy?
How's it? All right. Oh, look at that.
So what kind of fruits do you make? Are they like tree fruits or?
They're just
pepper
like,
fruits or-
yeah, they're just like Mojavians. Yeah. Pretty well, you know.
Few spines that fall off when it's completely ripe.
Yeah, but then, you know, some that are a little bit more towards Corellia that I had with that other cross. They'll be a pretty spiny, like,
But are they a moist fruit or?
they're all moist. They're all moist. Yeah. And these here, you know, since I used 2 Mojavensis as the parents, most of the fruits on these have pretty well come out a lot like Mojavensis. So.
You bringing a bunch down?
No, I'm not gonna make it this year, but hopefully Steve's told me about it, and I'll try to make it down next year with a bunch of plants.
Yeah.
So.
How much do you